Hello, my name is Ashley. I am a tutor at Chegg Tutors. The subject that I tutor in is in statistics. Today I'll be talking about counting and statistics. In statistics, we refer to counting as techniques used to count the set of possible outcomes, which is in two different ways. The first being in combinations, and the second is in permutations. In combinations, you're trying to find the outcome from using independent variables, and since they are independent variables, they do not affect each other. And to find that, you're going to use this formula, which this is the combination formula. N represents the number of things that you're choosing from, and then K represents the number of, well, how many you're wanting to choose. And then C is just stands for combination, so basically N choose K. And to do that, you're going to use a formula N factorial over N minus K factorial divided by K factorial, which that ends up being N factorial over K factorial times N minus K factorial. As you can see here, I have a combination example. We're going to figure out how many different ways that we can change 6 letters in 4 spots. A through F, I have letters A through F up here. So we're going to set up the problem with 6, choose 4. So now we have that. We're going to break it down more and write it into the formula. So we're going to do 6 factorial over 4 factorial. You want to make sure that you're using the parentheses, because if you do not, it will mess up your problem, because you'll end up multiplying 4 and 6 factorial and then subtracting that. But then we're going to do 6 minus 4, close parentheses, exclamation mark, well, for factorial. Then that's going to equal 6 factorial divided by 4 factorial. Then 6 minus 4 is 2. So if it's 2 factorial. And then you're going to want to break it down even more, and you're going to do 6 times 5 times 4 times 3 times 2 times 1 all over 4 times 3 times 2 times 1, and then you're going to want to break down 2 factorial, so you're going to multiply that by 2 times 1. Alright, as you can see here, we're going to start to factor these out. So you're going to factor out 2 times 1, because it's in both the numerator and the denominator. And you can factor out 3 and 4, because it's at the beginning. And we're going to go ahead and factor out the 1, because multiplying 1 and 1 doesn't really do anything. And you can factor out the 2 into 6. So then you're left with 3 times 5. And 3 times 5 gives you 15. So the different ways that we can change out the 6 letters in 4 spots is going to be 15 different ways. Alright. In the second combination example I have, Aiden is packing his bag for vacation. He has 5 action figures, but he can only fit 3 in his bag. How many different combination of toys can he take? And for this one, you're going to set it up the exact same. You're going to do 5 combination 3. So you have 5, but you want to choose 3. And then you're going to set it up. You're going to do 5 factorial. Then you're going to do 3 factorial. Then you're going to open parentheses, 5 minus 3, close parentheses, factorial. And then you're going to want to subtract that. So you're going to do 5 factorial then 3 factorial times 2 factorial. And then you're going to break it down and then show your factorial. So we're going to have 5 times 4 times 3 times 2 times 1. Then you're going to divide all that. Actually, let's redraw that. And then you're going to divide all that by 3 times 2 times 1 times 2 times 1. And just like we did in the first problem, you're going to want to factor these out. As you can see, we have 2 times 1 in both the numerator and denominator. And you can factor out the 3 because it's up at the numerator also. And then multiplying by 1 doesn't do anything, so go ahead and cross that out. And then you have 2 at the bottom, which 2 goes into 4, so you can divide that, and then you're left with 2 times 5. And then we're left with 10. There is 10 different combinations of toys that Aiden can take for a vacation. And now we have permutations. Permutations is trying to find the outcome using dependent variables. Since they are dependent variables, they do affect each other. As you can see, we have another example. We're trying to figure out how many different ways we can change 5 letters and 3 spots without repeating letters, because it's dependent. So we're going to set up the problem here. Got 5. Then you're going to do the P, and then 3, and then that will equal 5 factorial, then 5 minus 3 factorial. Okay, so then you're left with 5 factorial over 2 factorial. And then you're going to stretch it out and expand your factorials, and you're going to want to have 5 times 4 times 3 times 2 times 1. And then you're going to want to break out 2 and 1. So you got 2 times 1. Alright. And as we're going to factor it out, and the only thing at the bottom is the same thing at the top, we're going to go ahead and factor out 2 times 1. And then you're left with 5 times 4 times 3. So 5 times 4 is 20. 20 times 3 is 60. So it's going to be 60 for that one. Well, 60 different ways that you can change out the letters. Alright, and now we have factorials, which we've been doing, but we're going to go ahead and do these. So 3 times 2 times 1. 3 times 2 is 6. 6 times 1 is 6. Then you're going to do 5 times 4 times 3 times 2 times 1. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. Then we're going to do the same thing down here. 6 times 5 times 4 times 3 times 2 times 1. 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360, and 360 times 2 is 720. So that's going to equal 720. Alright. And then we have 0 factorials or 0 factorial. And to do factorials, you're going to want to do n times n minus 1 times that by n minus 2 times that until you get all the way down to 1. So if we're going to go ahead and do 3 times 2 times 1, which gives us 6. 2 times 1, which gives us 2. And then 1, which is 1. And then for 0 factorial, it is going to equal 1. Alright, now we have another permutation example where the possible 3-letter word without repeating letters. Well, yeah, not numbers, letters. So we got, since there's 26 letters in the alphabet, we're going to do 26 times 26 times 26. We're going to do 26 times 26 3 times because 3-letter word. 26. Cute. And then since we're not repeating them, it's actually going to have to be 26 times 25 times 24. And to set that up in a permutation example, well, permutation way, you're going to do 26p and 3. And then you're going to want to break it up into the factorial, which is 26 factorial. Divide that by 26 minus 3 factorial, which will give you 26 divided by, 26 factorial, divide that by 23. And this is where I broke out my calculator. But you can just go ahead and do it in your calculator, and then you'll end up with 15,600. That's how many different words you can get. Thanks, guys.